Hello everyone, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Now we are going to discuss very important numericals, expected numericals from theorems. That is important topic of circuit theory or network. And this session is important for electronics, electrical and instrumentation branch, right? And especially for GATE 2023, but it is also important for engineering services exam, ISRO, DRDO, BARC and other competitive exams, including your semester also. Okay, now this is the most expected questions on theorems. You are on BYJU'S Exam Prep, right? So let me know that sound quality, picture quality, everything is fine. Everyone please inform me. 1 minute. Okay, everything is fine now. Now, this is my introduction. Myself Sanjay Rathi, 21 plus years of teaching experience, and I have qualified and selected for engineering services exam that is conducted by UPSC, AIR 16 in ECE 2005, AIR 21 in ECE 2008. I worked as Deputy Director in Ministry of Power and I have mentored more than 1 lakh students for these exams, right? And according to my experience, you have to get the command over circuit theory or network, and especially on what theorems. Number of related numericals in analog from network, right? Machine, power system, power electronics. Yes, if you do you want to get the command over the core subject, then that is the basic subject, important subject, conceptual subject. Okay. So already I have taken number of topics like Thevenin's theorem with dependent and independent sources, Norton's theorem, number of questions on Thevenin's and Norton's, maximum power transfer theorem, maximum average power transfer theorem, superposition theorem, Telegans, reciprocity and duality. And now it is time to solve some important numericals. Are you ready to solve some important numericals? Use your copy, pen and calculator to solve all these numericals. Okay, so that is the 90% scholarship test, that is on 15th May at 11 AM. Register now on what? BYJU'S Exam Prep. This is for you. It is a golden opportunity for you. This type of numericals you can take a screenshot of this. One by one I will solve. Try to solve this question on rough pages and give me the answer on comments box. That is the value power absorbed by the value of the power absorbed by the load resistor at maximum power absorb condition. What is the maximum power transfer theorem? You have to apply the maximum power transfer theorem, and what will be the power given to the load. Okay, so dreamer, very good evening. And please share the link of this session, everyone. Like the session and subscribe our channel. Okay. So this is a 12 ampere battery. This is the 4 ohm resistor, 18 ampere battery, 36 volt battery, 6 ohm. You have to calculate the maximum power across this load. Here we are using only independent sources. Okay. Then second question. I will solve this. In the circuit shown in the figure, find the value of VTH and RTH. Simply you have to find the VTH and what will be the RTH. There is a dependent source 0.1 V1. This is the 4 volt, this is the 5 ohm, right? And that is the V1. From this point to this point voltage is what? V1. You have to calculate the VTH and RTH across this terminal. Then third question again on dependent sources. This is the current I1. On this I1, this is the 5 I1, this is the I2. On this I2, this is a 2 I2. This is a current controlled current source. This is a current controlled voltage source. I1 and I2. You have to find the RTH at this point. RTH at this point. And try to solve this question. This is very important questions, right? 3 questions. Again, on questions on superposition theorem, very basic question, everything we will discuss. This is very important question because you are going to get the RTH, that may be what? Negative value. That may be the negative value of RTH. I will explain what is the concept of negative value. Okay, I think now you are ready. Okay, then to try to solve these three questions, first, second, third. Now we are going to take very important session for you. Please subscribe our channel and press bell icon so that you will get the notification. That is, this time the GATE 2023 is conducted by what? IIT Kanpur. Okay, so GATE 2001, what was the pattern for electronics and electrical student? GATE 2007, again that is conducted by what? IIT Kanpur. GATE 2015, now that what? GATE 2023. What will be the expected topics? What are the important topics? Weightage analysis, each and everything for electronics and electrical branch by Ashutosh sir and by me tomorrow at 10 p.m. This is very important session for you. Okay, now that is the question. Everyone please give me the answer for this particular question. Okay, please try to solve this question. The value of power absorbed by the load resistor RL at maximum power condition, maximum power absorb condition. What is the maximum power absorbed condition? If you want to solve this question, you have to apply what? You have to find the VTH, you have to find the RTH across this A and B. Already I have discussed, because now we are going to solve questions across A and B. You have to find what? VTH and RTH. And once you will get the VTH and RTH, then what should be the value of RL? For maximum power transfer theorem, RL should be equal to RTH. RL should be equal to what? RTH. And then in that condition, what will be the maximum power? VTH square by what? 4 RTH. VTH square by 4 RTH. Okay, तो ये आपका क्वेश्चन बनेगा. Now बताइए जरा, you have to find the VTH and RTH. Just I am giving you the hint how to solve. First of all, remove this. Right, remove this. And then this is terminal A and that is terminal B. Then first of all, find a VOC here. How to find a VOC here? VOC. Let I am giving you very simple hint here. Let this is the voltage V1. Let this is the voltage V2. Let this is the voltage V3. So what is the V3 here? V3 is nothing but VOC. So V3 is nothing but VOC. You have to find the V3. But always remember, this is the V1, that is the V3. There is a voltage source. Then we can apply the V1 minus V3. V1 minus V3 is equal to 36 volt. That is the first equation. How to find the VOC? I am giving you the concept of what? Super mesh analysis. What is the super nodal analysis? So what is the super nodal analysis? Now you can write the voltage at this point. When I am writing the super nodal equation, it will become, what is the incoming current? 12 is equal to V1 by 4, V1 minus 0 by 4 plus V1 minus V2 divided by 12 plus, now at this node, V3 minus 0 by 6 plus V3 minus V2 by 15. V3 minus V2 divided by what? 15. That is the first nodal equation, that is the KCL at these two nodes simultaneously. This is called super node analysis. V1 minus V3 is equal to 36 volt. That is the second equation. Now you can write the KCL at this point. What is the outgoing current? 18 plus what is the outgoing current? V2 minus V1 by 12. V2 minus V1 by 12 plus V2 minus V3. What is the outgoing current? V2 minus V3 by 15 is equal to what? 0. Now we are having the three equations and three unknowns. This is very easy to solve this numerical, right? And ultimately you have to find the V3, because V3 is VOC. From these three equations you are going to get V3 is equal to VOC is nothing but VTH is equal to 36 volt. So try to solve this question, everyone. This is the equation number 1, that is the equation number 2, this is the equation number 3. And this is called super nodal analysis or super node analysis simply. Once you will get the VTH, then how to find the RTH? RTH, to find the RTH, first of all make it short circuit. This will act as short circuit. These two current source will act as open circuit. Remove this current source. Remove this current source. And you are going to get the RTH. What will be the RTH? Very, very simple question. How to find the RTH? Because it is a short circuit, it will short circuit the 12 and 15. Then what is the RTH at this point? RTH is nothing but 6 parallel with the 4. That is nothing but 24 divided by 10, 2.4 ohm. 2.4 ohm is the RTH. Then what will be the maximum power? Maximum power is given by VTH square by 4 RTH. Already I have explained all this concept. Watch my previous series. VTH square by 4 RTH means what is the VOC? 36 square divided by 4 into 2.4. 36 square divided by 4 into 2.4. Use your calculator and give me the answer. What will be the answer? 36 square. $135 watt. $135 watt. So the answer is what? C. What about the question? The question is what? Very simple, right? But time management. Within time we have to solve maximum 3 minutes. 2 to 3 minutes in GATE exam. Okay. If suppose we are taking more than 2 to 3 minutes, then it will become very difficult to solve other questions. Okay. This is because it is a very, very simple question. Means we have to apply the KCL, KVL, nodal analysis, super nodal analysis. You have to decide all these things. Okay, then next question. Next one. For the network shown in the given figure, find the Norton's current assuming 2 ohm as a load. Very simple, very, very simple. Norton's current, this is the load, 2 ohm resistor, 1 ohm resistor, 4 ohm resistor, 28 volt, and this is the 7 volt. Yes, please give me the answer. क्या होगा भाई इसका आंसर? Right. For the network shown in the figure, find the Norton's current assuming 2 ohm as the load. If this is the 2 ohm as the load, what is the Norton's current means? Norton's current means short circuit current. Remove the 2 ohm resistor, make the terminal short circuit and find the current. Find the current. That this is the A, this is the B. Remove the RL, make it short circuit and find the value of the current. Very, very simple question. This is the R1. Everyone give me the answer in the comments box. This is R3. What is this? 7 volt. This is the 1 ohm. 4 ohm, 28 volt. This is I1. This is I2. That current is I1 plus I2. What is the ISC? I1 plus I2. Always remember, when it is short circuit, what is the voltage at this point? 0. I1 is equal to 28 by 4. What is the I2 is equal to? I2 is equal to 7 minus 0 by 1. 7 by 1. 7 plus 7. What is the 7 plus 7? 14 ampere. That is what short circuit current. 14 ampere is the answer for this question. Okay. 14 ampere. How much time is required to solve this type of questions? Within 1 minute we can solve this type of questions. Short circuit current. Norton's current means short circuit current. 14 ampere. Now, next one. First of all, try to solve this question, then we will solve. Yes, this is the question. And then we will solve that question. In the following circuit, find the effective resistance faced by the voltage source. It is a very tricky question. Always remember, in number of cases, input resistance is asked. For example, in analog, what is the input resistance seen by the voltage source? What is the input resistance seen by the current source? This type of questions we are getting. What is the input resistance of a particular amplifier? Common emitter, common collector, common base, common source, common drain, right? Common gate. We have to find the input resistance. What is the meaning of the input resistance? In the following circuit, find the effective resistance faced by the voltage source. That is nothing but effective resistance means what is the input resistance seen by this voltage source? Vs. That this is the input resistance. Always remember, let this is the current I. What is the meaning of the input resistance seen by this or faced by Vs? This is nothing but II. Voltage, value of the voltage divided by the current given by the battery. That let this is the current given by the battery. Now what is the current here? There is a dependent source I by 4 here. And this is the current I here. Now this is right. Okay. Please try to solve this question. Okay, thank you, Dunes. Now, if you want to crack the GATE 2023 with job, yes, it is possible. Tomorrow we are going to take one important session. That is what this time that GATE 2023 will be conducted by what? IIT Kanpur, right? And we are going to give you the idea which type of questions and which type of pattern, right, in coming exam GATE 2023, right? And what are the important topics? What are the important subjects? Each and everything we will discuss, okay? And that is what, again, in every week we are going to take important topics from important subject. For example, in this week already I have taken what? Theorems, complete theorems from network or circuit theory. Just after that, or 15th onwards, right, new topic will start. To subscribe our channel, simply join these sessions. We will here to complete the important topics. What is the answer here? Now, very simple question. Try to understand. If this is the question, this is the I by 4, this is the I minus I by 4, that will be the current. I minus I by 4, that is nothing but 3 by 4 I through the 4 ohm resistor. Subtract 1 minus 1 by 4, 3 by 4 I, and again, what is the current here? I here. How to find the Vs by I? Write down the KVL. You will write minus Vs, this is the minus Vs, plus 4 times of 3 by 4 I is equal to 0. Vs is equal to 3I. What is the Vs by I? This is called Rn. Vs by I, that is nothing but 3 ohm. That will be the result for this question. Vs by I is equal to what? 3 ohm. Okay then. The answer is 3 ohm. This is numerical answer type question, NAT. Answer for this question is 3 ohm. No negative marking in numerical answer type question. Okay. Next question. Give me the answer for this one. Certain network consists of 2 ideal voltage sources. In a particular network, there are 2 ideal voltage sources and a large number of ideal resistors. Okay. The power consumed in one of the resistor is 4 watt. One of the resistor is what? 4 watt. Right. When either of the 2 sources is active and the other is replaced by the short circuit, that is, it means we have to use the concept of what? Superposition theorem. When we are considering the one voltage source, the other should be 0. Since both are voltage sources, when I am considering one voltage source, then other should be what? Short circuit. To make voltage source 0, we have to make it what? Short circuit. two sources is active, the other is replaced by the short circuit, the power consumed by the same resistor when both the sources are simultaneously active would be simultaneously. Okay, in previous class already I have given what is the answer for this type of questions. We have solved one question on this. Let that is the network, any network, let this is one resistor. What are the possibilities? Plus minus V, there may be another voltage source plus minus V, V2 and V1, and because of this, that is the what is the power across this RL or one simple resistor, 4 watt 4 watt. Okay, no problem. P1 is equal to 4 watt, P2 is equal to 4 watt. But it may possible that there may be the second situation, the polarity of the voltage is reversed. We have no idea. V2, right? Again, when we are applying the superposition theorem, the power is what? V square, right? We can write the power is equal to what? V square by R, or power is equal to what? I square into R. It doesn't matter what about the voltage. It may be voltage is negative or what? Positive. The power will remain positive, and that's why in this particular question 4 watt is given. Okay, but there may be the possibility that the polarity is reversed. We can't apply the superposition theorem to what? Power calculation. Then how we can calculate? Always remember, first let the voltage is V1. Because of the superposition theorem, let this is the V1 is the voltage across the R because of the source 1. Because of the source 1. Then what will be the P1? V1 square by R. V1 square by R. Right? Then what will be the value of V1? Because the value of the resistor is not given, you can take R is equal to let 1 ohm. Then it is called normalized power. Then it is called what? Normalized power. Because again we have to calculate the power across R. I am assuming let R is equal to 1 ohm. What is the V1? V1 is nothing but root over P1. Similarly, you can say because of the second source, voltage is V2. So what is the power? V2 square by R, that is the V2 square, because R is 1 ohm. What is the V2 is equal to root over P2. Now, it is a general case. It is a general case. Then what will be the V1 in R case? Root over 4 watt. It is given in the question 4 watt. So it may be plus minus 2 volt. What will be the V2? Root over 4. Again there is a 4 watt. It may be plus minus 2 volt. 2 volt. So we are using the superposition theorem to find the voltage or current. So what will be the total current? This is because of the source 1. This is because of the source 2. So total voltage. What will be the total voltage? V1 plus V2. But what are the various possibilities? Both are positive. 4. One positive, another is negative. 0. This is negative, other is positive. 0. And both are negative. Minus 4 volt. So there are 4 possibilities, right? Both may be positive, one positive, one negative, one negative, one positive, and both may be negative. So there are 4 possibilities. Then what will be the overall power? V square by R. We are taking the R as a 1 ohm. If I am taking this 4 volt or minus 4 volt square, 16 watt. 16 watt will be the power, and when I am taking this 0 volt, what will be the power? 0 watt is the power. So there are 2 cases. In one case the answer is what? 0, and other case 16 watt. 16 watt, right? Now already I have given you the very simple formula that P1 plus P2 plus 2 times of root over P1 P2. अब यहाँ पर in this case P1 plus P2 plus minus 2 times of P1 plus P1 into P2. There may be a 2 cases you can find. Okay, this is the value, right? There, second case, you can directly use within 30 seconds you are going to get the answer. One from the 16 watt, that the second is what? 0 watt. 0 watt, that is the shortcut for this particular question. Okay, अब देखते हैं जरा नेक्स्ट क्वेश्चन क्या है. अब आ जाते हैं, ये तो हो गया आपका सुपरपोजिशन थ्योरम पर. अब आते हैं नेक्स्ट क्वेश्चन ऑन द थेवेनिन्स थ्योरम. In the circuit shown in the following figure, find the value of VTH and what RTH. In this question, we have to find the VTH and what RTH. What is the VTH and RTH? Very, very simple question. Try to solve this question. Now, this is the 0 point V1 voltage controlled current source. It depends upon the V1. This is the V1. This is a independent source 4 volt battery. Then first case, first find the VOC. How to find the VOC, open circuit voltage? 0.1 V1. If it is open circuit, what will be the current here? 0. This is V1 is nothing but VOC. You have to find the V1. The same current will pass through this. Why? Because this, in this branch the current is 0. Now write down the KVL in this loop. You can write the V1 is equal to 4 plus 0 V1 into 5. Then it will become V1 1 minus 0.5 is equal to 4 volt. What is the V1? V1 is nothing but VOC is equal to 4 divided by 0.5, that is 8 volt. This is the Thevenin's voltage VTH. So don't worry about the dependent sources. Don't worry about the dependent sources. Simply we have to apply that this is the open circuit, this is the voltage V1 and this is the 0 point V1. We have to find the V1 and that is the value. How to find the RTH? How to find the RTH? Okay. Some student will connect a 1 volt battery, or already we have the VOC. Already we have the VOC, then what is the RTH? VOC upon ISC. VOC upon what? ISC. Make it short circuit. Very simple calculation. When I am making it short circuit, you can find the ISC here. When I am making it short circuit, V1 will become 0. When this will become 0, this current source will act as open circuit because this is 0. Remove this. Now write down the KVL in this loop. Write down the KVL in this loop like this. So this is the ISC will flow like this. When I am writing the KVL, it will become minus 4 volt plus 5 into ISC is equal to 0. What is the ISC? Is equal to 4 by 5 ampere. Very easy. Now you have the VOC and ISC, then what will be the RTH? VOC upon ISC, that is VOC 8 volt divided by 4 by 5. This will become 2 into 5, that is the 10 ohm. 10 ohm is the value of RTH. 10 ohm is the value of RTH. So this is how to find the Thevenin's resistance in this question. So this is the VOC upon ISC. Very, very simple question on dependent source. So when some student will ask her, I want to use the 1 volt battery to find the RTH. Okay, no problem. If only RTH is asked, then you can use. But already VTH or ISC, VTH or RTH asked, because already we have VOC, and that's why I am using what? VOC upon ISC. You can go for what? 1 volt battery, no problem. Yes, connect a 1 volt battery here. I am giving you the shortcut for this. If only RTH is required, then you can use here 1 volt battery. Only RTH is required, then you can use. external 1 volt battery is connected here, V1 will become 1 volt, and that's why it will become 0.1, because V1 is 1 volt. Same current 0.1 here, right? Let this is the I here, because that we have to find the RTH, that is nothing but 1 by I. 0.1 plus I, that is what will be the current? 0.1 plus I. Write down the KVL. You have to make it 0. Always remember, when I am connecting the 1 volt battery here, what about the independent sources? It should be equal to what? 0. Then you can write KVL here, -1 plus 5 into 0.1 plus I. Okay, is equal to 0. I think this is the KVL. Now, what is here? -1 plus 0.5 plus what I is equal to 5I. Is equal to 0. Check my calculation, and this is the this is no I. 5.5 5I. Okay, then what will happen? This is the minus 5I is equal to 0.5. What is the 1 by I? 5 divided by 0.5, that is nothing but 10. We are getting the same answer, that is the, yes dreamer, that is the 10 ohm by using the VTH, and when I am connecting the 1 volt battery, or that is you can directly use the ISC upon VOC. Okay. So always remember, the dependent sources will act as what? Short circuit. Now, next one. So this is the question. Yes, please. The value of the current in the circuit given below is by using the superposition theorem. When I want to apply the superposition theorem, what will be the value of I here? Superposition theorem. This is the dependent source. When it is written here 8I, 8 into I. No doubt we are using the symbol for dependent source, but if it is given like this, but if it is written as 8 into I, again it is a dependent source. Current controlled current source. Current controlled current source here. This is a 30 volt battery. This is the 6 ohm resistor, 4 ohm resistor. Now you can convert this 3 ampere and 4 ohm into what? Voltage source, and this I is equal to what? I1 plus I2 according to the superposition theorem. I1 plus I2. So first of all give me the value of I1, and then give me the value of I2, and then find the value of total I, and that is called the superposition theorem. So how to find? Always remember, in case of superposition theorem, there are two batteries. One is what? 3 ampere battery, another one is what? 30 volt battery. Let this is the first one, this is the second one. So when I am considering the first one, then second, this current source will act as open circuit. What will be the diagram here? Let current source tends to what? Open circuit. This diagram will become very simple question. 36, this is the 30 volt, 6 ohm resistor. This will act as open circuit, 4 ohm resistor. And what about the dependent source? This is the 8I1, because now the I will become I1, 4 ohm resistor. And this is the 2 ohm. And you have to find I1. Okay. Very simple calculation. 30. What is the current here? I1. What is the current here? 8I1, I1. So what will be the current here? 9I1. That 9I1 is distributed 8I1 plus I1. Now you can directly write the KVL. It will become minus 30 plus 6 into 9. That is nothing but 54I1 plus 4 plus 2 6I1 is equal to 0. So what is the I1 is equal to 30 divided by 60, that is 1 by 2 ampere. 0.5 ampere. This is because of 30 volt battery. That is because of 30 volt battery. Yes, Adityaraj, bilkul. Sir, why means why the current source will act as open circuit? Yes, in superposition theorem, when we are considering one battery, for example, I am considering the 30 volt, this should be equal to 0. And to make the current source is equal to 0, it should be act as what? Open circuit. And when we want to make the voltage source 0, it should act as what? Short circuit. That is the reason. Okay, Aditya? Now, in second case, when I am considering the 3 ampere current source, then you have to make 30 volt 0. You can convert the 3 ampere into 4. 3 into 4 is what? 12. You can convert this voltage source into current source. What will be the diagram? Second case, this 30 volt battery will act as short circuit. This is the 6 ohm resistor. This will become 8 times of I2 according to the superposition theorem. Now I am converting this 3 ampere into voltage source. 3 into 4, that is the 12 volt. And one resistor in series. What is the resistor value of the resistor? 4 ohm. This is the 12 volt. And here it is the 2 ohm resistor. And let this current is what? I2 according to the superposition theorem when we are considering the second source. Now this is the 6 ohm resistor. Again 8 I2. What will be the current? 9 I2. Write down the KVL. KVL means it will become 6 into 9 I2 plus 4 plus 2 6 times of I2 minus 12. This is the minus 12. I am writing the KVL is equal to 0. So what is the I2 is equal to 12 divided by 60, 1 divided by 5, that is nothing but 0.2. From this we are getting the 0.5 ampere. From that we are getting the 0.1. So what is the I is equal to I1 plus I2. 0.5 plus 0.2, that is equal to 0.7 ampere. What I want to explain through this question, if the dependent source is given, then how to solve this type of questions? Simply superposition theorem. I2, then it will become 8 I2, I1, then it will become 8 I1. Almost similar type of calculation we are using. This is the 9 I1, 8 I1 and I1. Already I have applied the KCL and then finally apply the KVL. Here we are using the three things. We are converting the current source into voltage source. Then we are applying the KCL on the diagram itself, and then third case we are applying the KVL, Kirchhoff's voltage law. Sir, which chapter? Complete theorems on top. On top, complete theorems. This is the series based on what theorems? Already I have taken the 6 to 7 lectures, and that is what 8th lecture on what theorems. Thevenin's theorem, Norton's theorem, with dependent, independent, superposition, maximum power, maximum average power. Right, now questions, question practice. I think this question is also clear, superposition theorem. But if you want to solve this question without using the superposition theorem, this is very easy one, very easy question. Right, how? This is a very easy question. Try to understand this. Watch this. At this node, you can directly write what will be the current, because this is the current I. What will be the current leaving this I? And this is what? 9I. This is the 3 ampere. That's why this will become I minus 3. What is the current here again? I. Okay, only distribution. Write down the KVL. When I am writing the KVL, it will become minus 30 is equal to minus 30 plus 9 into 6, 54I. Plus 4 into I minus 3 plus 2I is equal to 0. This will become minus 30 plus 54I plus 4I minus 12 plus 2I is equal to 0. 54 plus 4 plus 2, 60I is equal to what? 42. So what is the I is equal to? 42 divided by 60, that is nothing but, you can solve it, 0.7. Right? 0.7, this is the 6, this is the 7 divided by 10. 7 divided by 10 is nothing but 0.7 ampere. So tell me which method is better. No, it is not necessary. But if it I1 and I2 is asked, this is a very simple method. Here how I am distributing, because this is the 9I, how I am getting 9I, because it is a 8I, and what is the final current I here? This I is distributed into 2 branch. What is the I distributed in 2 branch? This is the 3I, this is the 4I, because ultimately here we are getting the I will enter into these 2 and leave these 2. I minus 3. This is very simple distribution. One, I am writing the KVL without voltage to current to voltage transform. Simply I am writing the KCL and directly KVL. In one step you are going to get the answer. So directly, if I is required, no need to calculate what? No need to apply the superposition theorem. If P1 power is required, what is the power because of first source, what is the power because of the second source, and what will be the value of I1 and I2, then you have to apply the superposition. Okay? Otherwise no need. Otherwise no need to apply the superposition. Directly we can find. Okay. Tell me what will be the answer. This is the E volt. It is not given, unknown. 4 ohm resistor, 2 ohm resistor, 4 ohm resistor, 2 ohm, 2 ohm, 4 ampere current source, it is given. This is the arrow. R, the value of R. In the following circuit, when R is equal to 0, the current IR equals to 10 ampere. IR is equal to 10 ampere. So make it short circuit. And in that case, the current is 10 ampere. The maximum power will be 2R. This is the question. What will be the maximum power across the R? Right? Across the R. You have to find. I am giving you the question. What is the maximum power delivered to R will be? But I am just giving. It is the question. Simple question. You have to understand what is asked in this particular question. Okay. Then because it is unknown and it is short circuit, then how to solve this question? Simply first of all convert it into what? Voltage source is converted into current source is converted into voltage source, and then you can find, or this current source is converted into voltage source. This voltage source is converted into what? Current source, and then current source to again voltage source. Make it short circuit, get the value of E, and then apply the maximum power transfer theorem. Okay, so how to solve this question, everyone? Give me the answer. What is the maximum power delivered to R? First of all, I am converting it into, this is the, convert it into a current source. It will become E by 4, sorry. 4 ohm, this 4 ohm are in parallel. This R will act as short circuit. This current source is converted into voltage source. This is the 8 volt. This is the 2. This is the 2. 2 are in series. Now this 4 and 4 are in what? Parallel. So it will become 2 ohm. Now when it is multiplied, it will become E by 2. Again convert it into voltage source. It will become E by 2. That is in series. This is the 2 and 2. This will act as short circuit. This is the 8 volt battery. This is the 4 ohm. This is the E by 2. Right? No. What is the short circuit current is given? Yes, we will calculate it. What is the short circuit current is given? 10 ampere. This is the I1. This is the I2. I1 plus I2 is equal to 10 ampere. So I can write I is equal to I1 plus I2. This is the 10 is equal to, what is the I1? E by, because this is connected to 0, this is the 0 volt. E by 2 divided by 4. This is the 4 plus, what is the I2? 8 by 4. This is the 10 is equal to E by 8 plus 2. From this you are going to get E is equal to 64 volt. What is the value of the unknown? E is equal to 64 volt. Okay. Now once you will get the E is equal to 64 volt, you can directly use E here in this diagram, because already we have used the source transformation. So E by 2, what is the E by 2? 64 by 2, that is nothing but 36 volt. Now actually this is the diagram. Now we have to calculate the maximum power. Then how to solve this? Again, that diagram is reduced, already it is reduced. What is the battery here? 36 volt. What is the resistor here? 4 ohm. This is already we have solved. 36. No, that is not 64 divided by 2. 32 volt. Sorry, this is called silly mistake. 32 volt. This is the 32 volt. Now here we are connecting the R, 8 volt. Now for maximum power transfer theorem, you have to calculate the VTH and what? RTH across R. Then what is the value of VTH and RTH across A and B? First of all, make the R open circuit. What will be the RTH? Sorry, VTH. Now students, this is the 4 ohm, this is the 4 ohm. If you want the VOC, VTH, very simple. According to the voltage division rule, you can write the VOC is equal to 32 divided by 2. How I can write? Because it is a 4 ohm. When I am making it 0, 32 divided by, because these two resistors are equal, 32 by 2 plus 8 by 2. And this will become 16 plus 4, that is what? 20 volt. 16 plus 4, that is what? 20 volt. This is the VOC. How to find the RTH? VOC upon ISC. Already we have the 20 volt ISC 10 2 ohm. 2 ohm is the RTH, because already short circuit current through the R is given. Or make it 32 volt 0, make the 8 volt 0, 4 ohm in parallel, that is nothing but 2 ohm. 2 ohm is the RTH. According to maximum power transfer theorem, P maximum, VTH is square by 4 RTH. Already I have explained this formula. Already I have derived and explained this formula. VTH is square by 4 RTH. What is the VTH? 20 into 20 divided by 4 into RTH, that is a 2. Right? What is this? 50 watt. 50 watt is the answer for this question. Okay? Very easy. Right? Already we have the value of ISC. You can also find the value of the VOC, and then VOC upon ISC you are going to get the RTH, and then you can solve this question, particular question. Okay. Yes. RTH is 2 ohm. It is right. Correct. RTH is the 2 ohm. Directly we can find. Make it what? Short circuit. Make it open circuit. And directly you can find the RTH across AB. RTH is nothing but 2 ohm resistor. Because we have to calculate the power, because that's why we are calculating the VOC, then we are calculating the ISC, VOC upon ISC, RTH 2 ohm, VOC square upon 4 RTH will give you the power. What is the efficiency? Already I have given you the hint. That is the question. Very simple question. But time management, accuracy plus time. You have to maintain what speed. Always remember time management. because we have to solve 65 questions in 3 hours in GATE exam, right? Or 150 questions in engineering services exam in 3 hours. I am talking about the technical paper, engineering services pre, right? If suppose we are wasting our time in easy question, then it will become very difficult, and that's why lots of practice is required. Try to solve again and again and again with different methods. Try to solve voltage to current transfer, current to voltage source, right? And then what simple KCL, KVL, or any other means you can solve this type of questions, right? Now that is the question. The circuit shown in the figure, the value of RTH. Now I will give you the one assignment also. This is the I1, this is the I2, right? Only the RTH is required, and that's why there are two dependent sources. Then how to solve this question? Simply apply here 1 volt battery here, 1 volt. Give me the answer. This is the I. Then what will be the RTH? RTH is nothing but 1 by I. This is I1. Okay. From the diagram, you can directly say that I is equal to 1 by 100 because the voltage across this one resistor is 1 by 100. What is the I1 equal to? I1 is equal to 1 by 100 ampere. Okay, no problem. This is the ohm. Then this, what is the 5I1? 5I1 is equal to 5 by 100. This is a voltage source. This is a voltage source. 5 by 100. 0.05. Okay. Now that is the I2. This is the 2I2. Try to understand. If this is the 2I2 current, if this is the I2 here, what will be the current here? This is nothing but I2. Because this is the 2I2, in this branch I2, then it will become I2. I2 plus I2 is 2I2. What is the current through this branch? I plus I2 is equal to nothing but I1. I plus I2. What is the I2 is equal to? I1 minus I. That is nothing but 1 by 100 minus I. Now I2 in terms of I, I1 already we have. Now finally you have to find the 1 by I. Write down this man. This one. Yes, superposition. In previous question you have applied the superposition. Okay, no issue. Then write down the KVL in this loop. When I am writing the KVL in this loop, what will be the KVL? Minus 1 volt. Remember, this is the minus 1 plus. This is the plus, this is the minus 5I1. What is the 5I1? Already we have calculated 0.05 plus 50 times of I2. This is the 50 times of I2. What is the I2 here? I2 is equal to 1 by 100 minus 1. 1 by 100 minus I. This is nothing but I2 is equal to 0. Already we have applied a KVL in this loop. Now, how to solve? Minus 1 minus 0. Plus 0.05. 50 by 100. 50 by 100 is nothing but 0.5. Minus 50 is equal to 0. Now please add all these and find the value of 1 by I, everyone. What will be the 1 by I is equal to? 50I is equal to, watch this. What is this? Minus 1 plus 0.05 plus 0.5. तो आप देखेंगे 5.1 minus 0.55. 0.45. This is the negative value. Remember that is the negative value. 0.45. What is the 1 by I is equal to? 1 by I is equal to 50 divided by 0.45. Right? So 50 divided by 0.45 and you will get the answer. Check my calculation. You can check my calculation, but In this case, we are going to get what? Negative value of what? RTH. Negative value of RTH. So write down the 1 volt battery, connect here, I here, that will be the current. This is the I1, that is the I2. Out of 2 I2, this is the current I2. What will be the current here? Again I2. This is the I2 plus I is equal to I1, or I1 is nothing but 1 divided by 100. 0.01, you can directly, or you can also write the 0.01 here, no problem, no issue. And then 5 I1 is equal to 5 by 100 volt. Okay, this is also correct. I1 is equal to I plus I2, that is also correct. I2 is equal to I1 minus I. Okay, 1 by 100 minus I. And then this is the KVL, minus plus 5 I1, that is 0.05, plus 50 times of I2. What is the I2? 1 by 100 minus I, this is correct. Minus 1 minus 0.05, 50 by 100, 0.5 minus 50 I. I think everything is fine now. Okay, no plus minus mistake, and that will be the answer. So in some questions you are going to get the negative answer also, negative RTH also. If this negative RTH already I have explained in Thevenin's theorem. Please watch my previous session on Thevenin's theorem. Already I have given, if suppose in particular numerical we are getting the negative RTH, then what will be the meaning of that? Okay, so that is the negative value. So how to solve this type of questions? This is assignment for you. Assignment number 1, everyone apply the superposition theorem, find the value of V. There are 3 independent sources. You can practice this question, V1 plus V2 plus V3. Solve this question by using the superposition theorem. This is the assignment number 1. That is the assignment number 2. And give me the answer in comments box, right? Give me the answer in comments box, right? Okay, and for PDF, join my Telegram channel, that is Electronics by Sanjay Rathi. So find the Thevenin's equivalent circuit for the network shown in the figure, which contains a current controlled voltage source. This is a current controlled voltage source. This is the I. You have to find the VOC and IS. Thevenin's equivalent means we have to find the VTH. You have to find what? RTH. There is some dependent sources. Now that is about what all the theorems. Already I have taken the number of sessions on the theorems. If you are watching all these sessions, you are going to get the command over the theorems. All expected questions I have discussed, and you will get the command over this topic. All theorems, and that is my experience. And tomorrow at 10 PM we are going to discuss GATE 2001, that is a paper by IIT Kanpur. Again GATE 2007, GATE 2015, GATE 2023, weightage analysis, most important topics, and this session is important for electronics and electrical branch. Please note the time, 10 PM tomorrow, okay, on same channel. You are on BYJU'S Exam Prep, the most comprehensive app for all exams. Like the session, share the link of this session, and subscribe our channel. Thank you very much, and good night.